All right, in the next part of the lesson, we have something called a depressed polynomial, and it doesn't mean that it's sad. It just means that it's going to be one less degree than what you divide it into. So really, if we think about synthetic division, okay, so if we go back to our first set of examples here we use synthetic division, and if we were to actually put this back into an equation, so here's our remainder, the constant, and the x term. So 3x minus 4 with a remainder of -8. So this has a power of 1. So the depressed polynomial is this part right here. This is our remainder. And it's just saying that this power should always be 1 less than what you divide it into. Okay, so we're just putting a name to something that we already know. The next definition, the factor theorem, says the binomial x minus r is a factor of the polynomial, and this is not a typo. This means if and only if. So that's the abbreviation for it. So if and only if p of r equals 0. So basically what that's saying is we're going to either use synthetic division or we're going to evaluate. If we get a remainder of 0, what we divided by is a factor. If we don't, then it's not a factor. So again, if we go back and look at our previous examples here, when we did synthetic division, these two are not factors. And what I'm talking about is the number, so this number right here, whether or not that's a factor. Okay. Now here, because we got 0, that means that this x plus 2, so our 0 of -2, that is a factor because it divides into this polynomial evenly. And that's going to help us factor so that we can solve. Okay. Right, so if we take a look at problem 6, it says determine whether x minus 5 is a factor of x cubed minus 7x squared plus 7x plus 15. And if it is, then find the remaining factors of the polynomial. Okay, so essentially this question is asking us to write this polynomial in factored form. Okay. So again, we're going to start with synthetic division. So I'm setting this equal to 0 and solving. So that means the 0 that we're going to divide by is a positive 5. And then our coefficients are 1, -7, 7, and 15. So the 1 comes down. 5 times 1 is 5. Add to get -2. 5 times -2 is -10. Add to get -3. 5 times -3 is -15. And add to get 0. So yes, x minus 5 is a factor. So x minus 5 times something is going to equal this polynomial. So we're just going to put this back into our equation. So again, remainder, constant, x squared term. So x minus 5 times x squared minus 2x minus 3 gives us this equation. And then we just need to decide if we can continue factoring this quadratic term. If we can't, then we're done. If we can, then we need to do that. So we're looking for two numbers that multiply to be -3, add to be -2. So we would use x minus 3 and x plus 1. And then we still have the x minus 5. So again, if we multiplied these back together, we would have x cubed minus 7x squared plus 7x plus 15. And we also learned from the previous section that if we wanted to, we could now finish solving. So if the problem said to solve by factoring, we would go through this process, and then our answers would be x equals 5, 3, and -1. Okay, but again, the question is asking for factored form. So for this type of problem, this is our answer. If it says to solve, then we would do this process. Okay, so make sure that you're paying attention to the directions. All right, so the next set of problems is the same thing. So it's giving us a factor, and then we're finding the remaining factors. So we're just trying to write it in factored form. All right, so again, we're going to start with synthetic division. So we're going to set this equal to 0. So we're going to divide by 3. So 1, 4, negative 15, negative 18. So bring down the 1. 3 times 1 is 3. Add to get 7. 3 times 7 is 21. Add to get 6. 3 times 6 is 18. Add to get 0. So yes, that is a factor. So right now we have x minus 3. So again, remainder, constant, x squared term, times x squared plus 7x plus 6. And then we have to decide if two numbers that multiply to be 6 add to be 7, and there are. We can use x plus 6 and x plus 1, and then we still have the x minus 3 from the beginning. So this is our final answer in factored form. All right, next problem. Okay, so again, setting this equal to 0, so we're going to use negative 1. So our coefficients are 1, 2, 2, negative 2, negative 3. First number comes down. Negative 1 times 1 is negative 1. Add to get 1. Multiply to get negative 1. Add to get 1. Multiply to get negative 1. Add to get negative 3. Multiply to get 3. Add to get 0. Okay, so again, remainder, constant, x squared, x cubed term. All right, so we have x minus plus 1 as our first factor, and then x cubed plus x squared plus x minus 3 as the second factor. And looking at that problem, we don't have the sum or difference of cubes, and no matter how I group them, we're not going to end up with the same set of factors. So that means that we don't know how, or we can't factor this any further. So this would be our final factored answer for this problem. And that is also going to conclude section 6.